Okay, now we have to build the function, okay? And so what we want to do is that we want to try and get all the pieces that right here, okay, and put them all together in a rewarding way. So the first thing that I want to look at is at this trig. What trigonometric function is going to best model this thing? And it looks like it could be cosine, right? Because cosine goes like this and then back down. And that seems to be the way that this particular problem is modeled out. Therefore, I'm going to go ahead and say that it's going to be best modeled by a cosine wave, okay? So, how do we find some other pieces here? So, looking at the A that we need, which is the amplitude, we would need to know where kind of like the center of this is, okay, of that sine wave, in order for us to find out what the amplitude is, because the amplitude, if you remember, is going to be the distance between the peaks and valleys back from the center, kind of like equilibrium point. And so, how would I find that? And so, if I look, the distance in between these are going to be 16, right? And so, if I go and I say the distance, oops, I take that back, that is not 16. The distance in between them is going to be 12. So that means is that I'm going to say, all right, well, if it's 12, then it had to move 6 in this direction, 6 in this direction, 6 in this direction, okay? And those are not 16s, those are the distances, okay? And again, the way that I got that 12, in case you didn't see it, is just the 14 minus 2 is 12. I accidentally added them earlier. And so we're looking at the amplitude is going to be 6, okay? So we just want to kind of put that off to the side. Now we got something a little bit trickier for B and C, and I'm going to show you how to do those. Okay, so B is always going to be, in my opinion, one of the more tricky things to get. And so I want to start with some facts that we already know, all right? So first of all, we know in any function with sine and cosine that the period is going to equal 2 pi divided by b, okay? And so that's an important fact. Now, in this one, we can find out what the period is before we can find b, which is uncommon based on what we've done so far. So to find the period, remember the period is when it starts to repeat itself. So measuring the distance from the two maximums there is going to give us 16, right? We would have 17 minus 1, and that's going to give us 16, okay? So, and given that the period is 16, we can solve for b by just combining these two facts, okay? So I'm going to let 16 equal the period and then solve for b. So I would have 16 equals 2 pi divided by b, and then just do some cross multiplying and whatnot, and it looks like b is going to be equal to let's see, pi over 8. All right, so you're just doing, again, some cross multiplying there with the algebra, and that will give you pi over 8. All right, so it looks like we got one of the harder parts out of the way. So let's tackle C. Again, for C, just like with when we're finding out what B was, is that we're given that information, or we can derive that information kind of quickly by looking at the graph. So if you look kind of in your upper left-hand corner here, this distance is 1, right, away from the actual y-axis. And so therefore that means is that it was shifted, the graph was shifted 1 unit to the right. So something important that we can note that is that if something's shifted to the right, we know that C is going to be negative because it always goes in the opposite direction, right? If it's going positive, then we know that C must be negative. Now, let's set up what we know about C, okay? So a phase shift, and I'm just going to go PS equals, right? And then we would have C divided by B. We know the phase shift, okay, and I'm going to leave this. We already know that the sign is negative, so I'm just going to go ahead and say that it's going to be 1, okay? And we already know what b is because we found it out in the last part, which is pi over 8. So now we can throw that in to this part and solve it out. Okay, so the phase shift is 1. C is what we're solving for here. And then B is pi over 8. And so therefore, we're just going to multiply each side by pi over 8 here. And that's going to go over here. And then at the end of the day, we get C equals pi over 8, but we know it's negative because we're going to the right, and so that's that. Okay, so almost done. We got some parts to final build and D, so let's take a look. Okay, so for D, that's not too difficult for us to get because it is going to just be this right here is the equilibrium. And when we were graphing out, like say if you take a cosine graph, right? And you're graphing cosine, and it would be like this, right? That part right here, the x-axis, would be in equilibrium. So that means is that we just took the entire graph and we shifted it up to the equilibrium right there. Now, what is that line? So we can take a look at this is going to be 2, right? So that's 2 meters above the bottom of the pool, plus an additional 6. And so it looks like the equilibrium line is going to be at 8. Okay, so and we're shifting upwards, and so we have D equaling 8. So now let's put all the pieces back together to form our final function. Okay, so we end up with the final form, and I'm going to write it over here, is going to be the height, let's just call it height above bottom pool, so h, with respect to seconds, is going to give me 6 cosine, okay, pi over 8 t minus pi over 8 plus 8, okay? And so the best thing that we can do at this point is graph it out, and I'm going to do my graphing on Desmos just because it's easy for me to hit the points on there and do multiple things. I'm going to be creating some videos that have to do with doing these out on your graphing calculators a little bit later, but let's just use Desmos to see where this thing is going. So I'm going to end this part of the video right now to keep the time down, and then we'll go on to using the Desmos graph to answer the questions below.